Welcome to the cold CO2 capture pilot rig. This is an experiment facility built mainly for two purposes, one of which is the separation of cold liquid CO2 from more volatile gas compositions, and secondly for storage experiments for cold liquid CO2 at different pressures. So in separating cold liquid CO2, the main principles here are first to compress some multi-component gas mixtures, and this is done with two compressor stages with intercooling in between, with a capacity of up to 120 bar. And thereafter, after compression, the liquid mixture enters a heat exchanger network where it is cooled to temperatures to below minus 50 degrees C, whereupon it is separated in two different separators, one of which separates the bulk of CO2 from the more volatile components, and secondly, purifying the CO2 to very high purity. And purities of 99.9% have already been achieved. And of course, when transporting liquid CO2, it is also important to have control over the development of the liquid and gas phases and potential pressure buildup during transport. And to know more about the phenomena that occur in this process, we are also able to do dedicated storage experiments, which is also ongoing presently, where we can store liquid CO2 at any pressure of interest. We can then measure the phases, how the compositions develop over time to see if there is any undesirable accumulation of certain components in the gaseous phase. And we can also monitor very closely the temperature developments in the tank to also understand more about the heat and mass transfer phenomena during storage. So producing cold liquid CO2 is of course key when looking at the specifications of the full-scale storage experiments, which is based on reception of liquid CO2. And in this rig, we can, for instance, test solutions that liquefy CO2 as an integral part of the CO2 capture process, which means that liquid CO2 is readily available upon separation with no additional needs for a dedicated liquefaction unit. So the capabilities of this rig have been gradually improved. We started off with testing binary mixtures of CO2 and nitrogen. And since then, we have also extended the capabilities to also allowing further chemical components, carbon monoxide, methane, and hydrogen, in addition to nitrogen and CO2. In the NCCS spin-off project MACH2, we have been conducting CO2 separation under pressure for 5-component mixtures, which is highly relevant for various novel types of hydrogen production processes, where you can integrate the CO2 liquefaction as an integral part of the CO2 capture part.